Chapter 12.6 Surface Areas and Volumes of Spheres. In a sphere, the diameter is a chord that goes through the center of the sphere and touches both the sides of the sphere. A radius goes from the center to any point that's on the sphere. The great circle is if you took a slice of the sphere that goes around or through the middle of the sphere. The formula for the surface area of a sphere is surface area equals 4 pi times the radius squared. In our first example, the radius is 4.5 inches. Surface area is 4 pi r squared, which gives us 4 pi 4.5 squared. .5 squared is 20.25. So surface area would equal 81 pi inches squared, which is approximately 254.5 inches squared. In the next example, we're asked to find the surface area of the sphere. The radius is 6.25 inches, so surface area would equal 4 times pi times 6.25 squared, which would give us 156.25 pi inches squared, which is approximately 490.9 inches squared. Now we're asked to find the surface area of the hemisphere. To find the surface area of the hemisphere, we're going to take half of the area of the sphere, but then we also have to add the area of the base. So looking at this, we would have 2 pi r squared plus pi r squared. So the surface area of a hemisphere would be 3 pi r squared. So 3 times pi, the radius is 3.7 millimeters. That would give us 41.07 pi millimeters squared, which is approximately 129.0 millimeters squared. Next, we're asked to find the surface area of a sphere if the circumference of the great circle is 10 pi feet. So we know the circumference is 2 pi r, and we need to find the radius. So 2 pi r equals 10 pi. Divide both sides by 2 pi. Pi's would cancel out, and we would have that the radius equals 5. So volume equals, surface area equals 4 pi 5 squared, which would give us 100 pi feet squared, which is approximately 314.2 feet squared. In example C, we're asked to find the surface area if we know that the area of the great circle is approximately 220 square meters. Now remember, the formula for area is pi r squared. If we look at the formula for surface area, is equal to 4 times pi r squared. So here's our area right there, pi r squared. So this is the area of the great circle. So the surface area would be 4 times pi r squared, which is 220, which gives us a surface area of 880 meters squared. For this problem A, we're asked to find the surface area of the hemisphere. So the surface area would be half the area of the sphere plus the area of the base, which would give us 3 pi r squared, because 2 pi r squared plus 1 pi r squared would give us 3 pi r squared. The radius is 4.2 squared. Which would give us 52.92 pi millimeters squared, which is approximately 166.3 millimeters squared. We're given that the circumference of the great circle is 8 pi feet. The formula for circumference is 2 pi r, and that it would equal 8 pi. Divide both sides by 2 pi, and we have that the radius is 4. Plug that into the surface area formula, and we have that the surface area is equal to 64 pi feet squared, which is approximately 201.1 feet squared. Next, we're asked to find the surface area of the sphere if the area of the great circle is approximately 160 square meters. So we know that pi r squared is equal to 160. Surface area is 4 pi r squared. So 4 times 160, which would give us 640 feet squared. The formula for the volume of a sphere is 4 equals 4/3 pi r cubed. In the first example, we're given that the circumference is 30 pi centimeters. The formula for circumference is 2 pi r, which is equal to 30 pi. So r would be 15 centimeters. So volume equals 4/3 times pi times 15 cubed, which is 4/3 pi, 3,375. The exact answer would be 4,500 pi centimeters cubed, which is approximately 14,137.2 centimeters cubed. In the next problem, we're asked to find the volume of a hemisphere with a diameter of 6 feet, which would make the radius equal to 3 feet. When we are looking at volume, we don't have to consider the area of the great circle because we're just filling up half of the ball, half of the sphere. So volume equals 4/3 pi r cubed which is 4/3 pi 3 cubed, which would give us 36 pi feet cubed, which is approximately 113.1 cubic feet. The radius is 8, so volume would equal 4/3 pi 8 cubed, which will give us an answer of 2,144.7 centimeters cubed. We need to go back up to B because I made a mistake on this one here because of the fact that we're only looking for half the volume. So let's redo this one here. So volume would equal 1/2 of 4/3 pi r cubed, which would be 2/3 pi, and the radius would be 3 cubed. Which would give us 18 pi feet cubed, which gives us approximately 56.6 feet cubed. So on B, we know that the radius is 40. We want to find the volume for half of the hemisphere, so volume would equal 1/2 of 4 pi 4/3 pi r cubed, which would be 2/3 of pi r cubed. Which gives us an approximate answer of 134,041.3 meters cubed. And that concludes our lesson of chapter 12:6.